Yeah, thank you for the introduction, and thanks everybody for attending this talk. For me, it's incredibly exciting to be here. I have been at GOTO a few years ago and greatly enjoyed the event, and also today and yesterday were wonderful days for me. I'm really happy to be here and have the exciting task to talk to you about reliability, which I really like doing, and I already did quite a bit at this event. So I think Zalando has an interesting position for this event and for the conversations that I had with a number of you, in the sense that it's relatively young. It's founded in 2008, and it's cloud native, and it has a strong operations focused. But at the same time, we are not the Facebooks, we are not the Google, we are not the Netflix, which have like very different kind of operations, data centers, and also very different financial capabilities to support an operations organization. So in this talk, I try to compress as much of the learnings that I could that fit this kind of SRE for the rest of us, how I would call it, like small, medium-sized companies. And I'm trying to present the things in a way that they are motivated, so you understand why we are doing these things, and they are transferable. At the same time, I will not just leave it as theory, but also give you a peek behind the scenes and really show you how operations looks like when you work at Zalando and the processes that we have implemented to solve our specific problems. So why would you listen to me? I'm Heinrich. Maybe you like me, or you have, I don't know why. But here's what I do and what I want to do and have done in the past. So I see myself as a reliability engineer. I really try to build a career around it and be the best reliability engineer that I can, as to help the industry solve problems. So when I started my first steps as a software developer, building very little applications, the first block, reliability, configuration management, logging, that were the problems that I ran immediately into. And I found out it was not really solved. We had Nagios and Ganglia, and the things were really different. And I was searching for solutions, and there were no solutions. And I think I got stuck in this problem space for the past 10 years. So my first industry job was as a data scientist at a metrics vendor called Seconus. So this were 5 years where I was working with a large variety of companies on reliability topics. And I started talking about statistics for engineers. Actually at SRECon, I think it's the single talk that has been there every year since 2015 at SRECon in Europe. And over the time, my roles shifted. I was in management for the last 3 years, leading the reliability group at Zalando. And I'm right now the senior principal SRE. It's not quite the title. I sneaked in the SRE, so it's usually called just principal engineer. But this is how I see myself. I engineer the processes at Zalando that are feeding reliability. What do we have on the menu? I will start with principles. These are things I fundamentally believe to be true. Then I will give you some context about what Zalando does, and you can compare how it compares to your context and which things are transferable. And then we are going through the operational practices. So in order to do anything and motivate other people to come along the way, I think it's critical to know about the mission. So what are we trying to achieve? And on the most fundamental level, we are trying to protect the user experience. This is what it boils down to. We are earning money only if our services are available and useful for the user. So that's our ultimate goal. We want to protect them from operational failures, but we have to keep an eye on developer productivity and on-call health. That is, to the best of my knowledge, the best way to express our mission as reliability engineers. And I extracted 2 rules out of this. The first one is obsess about user experience. That is, if you take anything away, then it's really the kind of North Star that always guides what we are trying to do. It's really about the user experience. And the second thing is about these guardrails, the on-call health and the productivity. And the way I like to conceptualize this is within this triangle. The North Star, the reliability, is the thing we try to optimize, but we always have to think about productivity and on-call health. And I mean, to give you an example, it's very easy to become a lot more reliable if you are willing to sacrifice productivity. Sometimes we have deployment bans where nothing moves. So yay, we are reliable, but it's not a good idea for the business to operate like that. And also there's always an urge to add more alerts, so you can like wear down your on-call responders, and in extreme case, just have them watch dashboards all the time, increases reliability. So if you are just understanding our mission as improve reliability, then that doesn't work. So at least you have to think about these two factors. And in fact, if you're thinking about it larger, then it's not just okay, you have to make these decisions, but you have to enable others to make the decisions. If your company is larger, you will not be the decision maker in many cases, but you have to rely on others navigating this. So for me, a lot of this is about enabling others to navigate this triangle, understand your position, where you are, and where you want to go in the context that you are in. And the second rule, it's still like hard for me to really accept this reality, but I think it's critical. So I'm a math guy. I really love technology. If I could just write assembly and think about high performance problems, I would be like a happy camper. But that isn't the path to reliability. Reliability is really a people problem and a technology problem. It's the so-called technical systems that we are engineering. And if we really want to make progress, we have to accept this reality and kind of get behind it. Otherwise, we will be not happy because we get frustrated. We don't understand what we are trying to do. And the second, still very hard truth for me is that the larger the company gets, the more the people problem are dominating. So if you are building your first website, I mean, for me, operating like a WordPress installation, I think setting a pingdom check would have solved a lot of my issues, which is something technical. Think tightening down your operational practices and then investing in dashboards and logging. These are really the first step that already get you a long way if you're relatively small. If you are having a bunch of teams, then knowledge sharing, debugging incidents that cross team boundaries becomes important in topics like observability, playbooks, maybe also operational review meetings, more meetings. And then finally, at very large companies, we have topics like warm cascades, so these meetings that feed into each other, risk management. I mean, who is excited about risk management, right? It's pretty far down the line, but it becomes incredibly important if you are dealing with large companies. And finally, sharing knowledge in communities and guilds, which are really running diagonal to the reporting lines. And yeah, it's important to have these processes working in this direction as well. So how do we engineer reliability in this environment? And it's not a software engineering problem. You cannot just have nice interface design or excellent Python engineering. That will not give you reliability. You have to understand it as a socio-technological system, and the best approach, I think it's still not perfect, still limited, but it's the best one I know, is systems theory or systems thinking, which for me, the entry drug was Donella Meadows' book. If you haven't read it, highly recommend to read it. So it's engineering complex systems in terms of thinking about them, conceptualizing them in terms of feedback loops, and here causal loop diagrams. And you see this also in this conference in another context. So this is a slide I stole from Martin Traits at Honeycomb. He was presenting a similar topic yesterday, and I was actually looking for a diagram like this for a long time because I think there is a ton of truth in this. If you are thinking about software and reliability, then these are the feedback loops you have to consider for a developer. Maybe even internal ones that are inside the head of the developer are also very interesting from a managing self and productivity point of view. But ultimately, it's about how all this connects. So you are interacting with an editor and have a linter giving you immediate feedback, and then you have maybe tests, and then we are mainly looking at this here, production telemetry. But since I didn't have Pingdom set up, I was relying on my customers to tell me that the WordPress blog was bound. So the general idea is always try to tighten the feedback loops, try to bring things closer to the developer so it also becomes faster and you become more productive. And we also learned that speed is safety in our business, which is also, I think, a lot of truth to it. So an example on how reliability engineering can look like. Don't look at this at, okay, let me try to understand it, but this is kind of, we call it the reliability flywheel. This is the process that we are currently following. I think it was the presentation could be better, and we will have some slides zooming in on some aspects of this. So let's talk about the context a little bit. Just real quick, Zalando, founded in 2008, is the largest fashion retailer in the EU. We have around 10 billion euros of revenue, around 50 million active customers, so quite a sizable business. Operating in 25 countries, exclusively in the EU. And we have around 2,000 software engineers on staff and around 3,000 microservices. So we have more microservices than software engineers, but it's a sizable organization. This is our service graph. It's not the current service graph. This one is, I think, from 2019. If you count the dots, it's not quite 3,000, grown a little bit. And I was giving last year a talk about how to operate this. And I was primarily looking at this as a technical problem back in the day and talking about distributed tracing and so on. But one of the fundamental truths I learned over the past year is that we actually need to think people and software together. So something that I think we are doing right at Zalando, which helps us at all to operate, is that we are really keeping the teams and the software very close together. You have Conway's law that tells you, your technological boundaries are evolving like the team boundaries. So you need to, the people, the technological structure need to follow the people structures. And the other thing is, you build it, you run it. You don't want to have walls between your operational group and the developer group. I mean, you can get away from it, certainly, but you are introducing a lot of friction into a very critical feedback loop. And for our systems, it's critical to embrace this principle. You build it, you run it, and do not put these walls in between. When I reason about processes and engineering reliability, this is my view on our organization. It's not this Death Star of complexity. I look at this in terms of people, applications, the hierarchy, the management hierarchy that gives it structure, and the platform. This is the concepts I think about. And fundamentally, we want to always move down. We have very expensive projects we are running through management, like a load testing project we may do for Cyber Week. This should become a team capability. So every week, teams should be able to autonomously run these load tests, which is then moving one step down. And ideally, teams shouldn't really do anything. It should be a platform capability, like scalability and resource planning is now a platform capability since we have Kubernetes. And in this way, we're trying to move down, and it's a lot more manageable to reason about it this way than to reason about it this way. So where do we stand as Zalando? So if you want to know what to copy from us and where to be critical, honestly, I would say we are pretty good at operating microservices that are integrated over REST. So this is what I call transactional microservices. So we have HTTP interactions that go back and forth between them. We got pretty good at protecting our business, which is maybe not the most important bit, but it's the thing that we kind of figured out. Business for us means revenue, which means orders. So it's the cart, it's the checkout, it's the payments area. Those are really excellent when it comes to reliability. And we gotten pretty good at high load events. So last Cyber Week, we had one incident that was the most important one at Black Friday. It was 20 minutes delay in pizza delivery for the situation room engineers. And we wrote a postmortem for that. So that was a success. We still struggle at understanding user experience. We are not really great. We want to move closer to the mobile devices, to the web, to understand how reliability affects the user. And we have no idea how to take care of data, have processes which are very multi-step pipelines, like delivering emails. These systems break in ways that we don't like. We want to get better at this. So if you know how to do it, please come talk to me. All right. let's dive into the different disciplines. And I tried to order them in a way that they are like most relevant to smaller companies and then going on to things that are only relevant in the context of like very large companies. So the first bit I think everybody needs, even the small WordPress blog, is the alerting. So why are we doing it? It's to reduce the time to detect. That's pretty straightforward. If you think about this in a systems engineering or systems thinking diagram, then this is what I ended up with. So you have a system that is in a state of normal operation that moves into a faulty operation state. You see already how hand-wavy it is. So it's always, a model is good if it's useful to describe something. So you have an arrow that goes down to normal operation, I call self-healing. That is maybe systemd restarting your service or Kubernetes scaling up or like things taking care of each other. We want that. We want our systems to be as self-healing as possible, and we want the feedback loops to be as tight as possible. Ideally, the process doesn't get in a faulty state. We don't have a seg fault, we have a checked exception. Ideally, if we run out of memory, we kind of restart and kind of tolerate the failure, so we have a tight feedback loop here. Alerting is a last resort. Alerting is if a human needs to be active right now, and I call, like, for this purposes of this talk, I'm just talking about paging alerts. So we are really like paging somebody, and we are talking about the efficiency of this feedback loop now. We are detecting that something is out of the ordinary, then we are creating an anomaly. Anomaly for us means something is wrong, but we do not know yet how severe it is. Does it affect the user experience or not? If it is affecting the user experience, significantly we are creating an incident, and then we are in this incident mitigation phase, and we will also write a postmortem for it. And the speed of this feedback loop is measured in 2 KPIs. It's the time to detect, so the first arrow, and the time to restore, which is the second arrow. So how effective your operation is kind of depends on how effective these 2 arrows are working for you. We have a very strong belief at Zalando that you should alert on the user experience and not on the server experience. So that is a concept called symptom-based alerts. I forgot the author of the blog post, but you can Google it and find some more information. So the philosophy is that you're always measuring user experience and you're alerting if the user experience is degraded. You are not trying, if you had an incident and realized, okay, if kind of this metric is over a certain amount, this may be a problem. You are trying to avoid this kind of alerts. They are in some cases acceptable. This is the discussion I always have with our Postgres teams and the infrastructure teams. They are saying, we really need these alerts, otherwise we are falling off a sharp cliff. Fine. Keep those alerts if you really know they are important for you. But if you are designing your alerts, it's always try to think about the customer experience and how to quantify it. If you have SLOs, then they make great alerts. And again, if you have an alert on CPU utilization, it's probably not what you want. That is an extreme picture, but it exemplifies this philosophy. So this is a burning data center, and you have happy users in front. As long as your users are happy, this is ultimately okay. I mean, probably you want to alert if you have fire because you are falling out a sharp edge once really everything starts collapsing. But the basic idea is the servers are extremely unhappy. They have a high temperature, they are churning, they have all kinds of problems, but the users are happy. So that's a problem you can eventually solve when you have business hours. You can make the servers happy again. As long as your users are happy, that's fine. That is what we want. And here's a concrete example on how an alert might look like. This one is literally from yesterday, and it shows you user pain. So add article to cart, mobile had an error rate of 0.28% over 6 hours. So it's a user-facing pain, quantified relatively close to the user, and is also giving you directions. So it gives you related playbooks. It gives you jump starts to your observability journey, so you can go to that link and start debugging from there. So that is like a best practice how we want the alerts to look like. here's the trade-off you are navigating with alerts. You increase reliability, but you decrease the on-call health. And in the worst cases, you are also decreasing the productivity very significantly if your team is just treading water trying to get on top of the alerts. So in order to balance this, we are using this table. Every manager on head to VP level is getting a sheet with all their on-call rotations. So every row represents one engineer which was on call for that week, with the number of pages that this engineer had each day. So we had one engineer which was paged on 1, 2, 3, 4, 5 days in this particular case. And we give a color coding score. So this was tolerable. Like, this was not good. As soon as it goes over 10, this is something we want to dig into. And we asked those managers to provide a quick explanation. Just saying, hey, okay, this was this situation. Teams are trying to clean up the alerts. This is how we try to balance the triangle. We don't want to be reliable just because we killed our on-call health. And this is a very pragmatic way. It's not very academic. It's really simple, right? You just count how many times somebody had to switch context. But it's effective at triggering the right conversations. So when we started doing this, we still had a lot of teams which were basically every day having multiple alerts. And that kind of triggered discussions in the team of saying, okay, either this is fine for us, we maybe have an on-call rotation which can support it, or it's something we need to invest. Dashboards. We use dashboards. In fact, every application is required to have a dashboard. We don't watch dashboards. We don't have this kind of things. And I clarified this also with the Honeycomb folks and say, these dashboards are fine. What you don't want is the dashboards that you're watching. Dashboards help you on your debugging journey. We are trying to reduce time to restore. We are trying to give you a head start into your debugging journey. The value of the dashboards depends on how much you can accelerate your feedback loop. And they are great for understanding service health in the context of a single team. So that are what they are for. This is how they look like. So I didn't talk about this. Yeah, we have a lot of managed services at Zalando, and so there are a lot of dashboards that teams don't have to build. So this is our Kubernetes dashboard, and you see all this kind of drop-downs at the top, so you can select your application. You don't have to build this. This is just for you, so you can make use of it. And it's kind of a curated best practice view. This is extremely simple, but used a lot. We have a very elaborate Redis dashboard. I leave you all to imagine why we have that. But there's a lot of operational experience that came into building this, and also a long guide on how to operate Redis. And similarly, we are embracing OpenTelemetry and standard signals from our applications as well. And there are certain parts of the lower level architecture that we can standardize. So here's a JVM dashboard. And I think the ones for Go and Python are basically useless, but I think this one has some value to it. So the best dashboards are, of course, the ones that you don't have to build. This is the TLDR of our Zalando dashboard guidelines. So from the transactional teams, we got a long document on how to build proper dashboards, and this is the gist of it. You should focus on the golden signals. You should cover entry points, dependencies, saturation signal, and then operational insights is the stuff you learn from incidents, graphs that may be helpful, and then storage. Just showing you a few of those. So the golden signals, this is a topic I think I'm covering in every single one of my talks for the past 10 years. It's requests, errors, duration, and saturation. I think we could do a much better job at representing this, but you are getting the idea. You get the global traffic of the service, you get the errors, you get the latencies, and you get everything that can be, like a resource that can be saturated. So how many pods, CPU utilization, and this kind of things. We also do red signals. Saturation is skipped for every major endpoint. We do a saturation row. So that definition of saturation is just everything that can be exhausted. And that's how that looks like in that specific case. And yeah, it kind of gives you a jump start into your debugging journey. But again, it's very team-focused, very service-focused, and but it provides value, and we want to have it. So next up is observability. And I think, yeah, observability has a lot of meanings, and there is, yeah, a lot of problems that it tries to solve. And fundamentally, I think it's the ability to answer interesting questions about your system. And there are very different kinds of questions, and there are very different kinds of observability. So I'm still super frustrated about very basic questions I was able to answer about my systems 10 years ago that I can't today. And maybe that's something for a different talk, but for me it's still embarrassing if I'm not able to tell you what the payload of an HTTP call was that was causing problems. It's like, we are so far detached from it, I cannot TCP dump it, and if I would be behind SSL, and it's going to be complicated. So that's, I think, a capability that we still need. I'm not able to tell you how often a function was called that I didn't pre-instrument. I'm still not able to tell you how many objects I've allocated of a certain type. Basically a heap analysis on my maybe Java process. This is capability we don't have, and I think a lot of good technology could be built to bring this very basic capability that as a sysadmin you kind of knew how to do, to bring that into this kind of microservice environment. But the type of observability, and let me move to the next slide, that is meant when most people talk about observability in this context is debugging distributed systems with failure domains that are crossing team boundaries and to understand user experience. And this is something different than going deep on your stack. It's really going wide and high on your stack. And I have this 2 slides about it. So this traditional monitoring with the dashboards, it really focuses on the domain of a team, and it focuses on service health. You are able to say, was my service healthy? Did it feel right? Was it on fire or not? You are not able to reason well about the user experience if your user experience is composed about multiple services. Here, if you are feeling a pain, if you have an incident, you know something is broken, but you have trouble to figure out which team to page. If you are playing the game of blame, saying my dashboard is green, the other dashboard is green. If you're playing the game of let's try to grab for this user ID between 5 different log files or log systems, then you have an observability problem. And this is what system like distributed tracing or this event-based databases are trying to solve. So they are a single observability database that is allowing you to assemble a context of events that are relevant, ideally tied to a user. So you want to know this specific user, which applications were involved, what did the user see, what was the user experience, and then also which team is responsible for operating the service. And let me show you how this journey currently looks for Zalando. We have built our observability on distributed tracing since 2019, and we are right now at a place where basically every major system is fully instrumented with traces. This allows us to go for a single operation, view home, and get a graph like this. This one has 236 spans, 236 events which are visible in the context of this single user transaction. And I checked the other day, we have some where it's over 1,000. So there's a lot of information you can have in that context. And finding out what is broken is super simple because it's red. You can click, you can get the logs for the event, you can get all kinds of metadata, and then you see what's the service and what's the team owning it. So I can go from the user experience is broken to this application failed to page this team, that's 10 seconds. It's even fully automated. So that's a system we call adaptive paging. So we can set alerts on the user experience that automatically page the right team, which is actually very much used for our top most important alerts. But it's not even necessary. The moment you have this kind of observability, you can do this inference very quickly, and it resolves already the major pain points. So here are the guidelines that we give to our developers with regards to observability. Use OpenTelemetry. The second is do everything you can with distributed tracing. This is why we are so good with operating microservices, because our developers really understand that they shouldn't put in interesting things in logs. They should put everything that happens in the context of an HTTP transaction into the trace, into the span. And that is surfacing it and the time when you needed it most. You have some stuff that you cannot do in this way. For example, data operations. This is why we are not good at it. But the thing you can do this way, it works beautifully. And for some stuff, you just need metrics and logs and use it for the stuff that you need it. That's the TLDR. One beautiful byproduct is that you can get these golden signals we saw on the dashboards very cheaply, very effectively, just from selecting a certain set of spans. You can also select certain cohorts, look for mobile, look for a specific market. If you have these attributes in your spans, you can get this kind of signals for like what's the user experience of a certain cohort. And here, that's the slide I've specifically created for this conference. It's the only time I will put code on here. It's something I'm quite proud of. Observability SDKs were the first thing I was working on when joining Zalando. This is a wrapper around OpenTelemetry. So we didn't just say, here, take the stock SDKs and have at it. We built relatively shallow libraries around it. And they do two things. A few more on the compliance side, but essentially it's auto-configuration. So you have here this Python code ops.initialize. This is doing all the integration, hooking up the backends, reading environment variables, figuring out where to send telemetry. And then we have like simplified access to key things we want to do. So if you want to add a span to a certain operation, you just add an annotation. And if you want to get a counter, we also have a simple creation methods around it. It's also something we do to bound cardinality explosion. So we kind of make it a little bit more harder to add additional attributes to like things that we count or like gauges that we expose. It's relatively shallow. It took a lot of time to build, but ultimately I think it's one of the platform capabilities. That stuff we don't want 2,500 engineers to do. We want to have a little bit more comfort around it. SLOs, next big topic, and it's a topic that is further up the maturity scale. Why do we have SLOs? And there are so many reasons for it, but depending on how you are holding it, you are trying to do different things, and to be really clear about your primary goals helps you to navigate the complexity. So we want to get a top-down understanding of reliability provided to the user. The other thing we discussed before is event-based, incident-based understanding of reliability. That's what we call Twitter-driven development. We're kind of just looking at the most recent things. SLOs allow you to go top-down. How reliable has managed address been? How reliable has view home been? And so on. So you are making sure you are not just following the latest things. And you can use SLOs for a lot of things, but the most value you can get out of SLOs is around steering engineering priorities. It's a very hard problem for engineers to figure out, or managers to figure out what to invest into. SLOs should be a guiding post. Here's a user experience broken. This is something we have to fix in the long term. So if you are rolling out SLOs and you are able to get a top-down understanding of reliability as experienced by the user, ideally along the value chain of your business, so they should be close to the business KPIs, and you can use it to make managerial steering investments, this is time to have a big party. That is a big success. You can also do different things with it. You can use it to quantify impact of incidents, and you can also do high-quality alerting, but it is traction. Focus first on the managerial steering. So there's another rule of operation here. Quantify the reliability of user experiences and target managerial steering for SLOs. This is how our SLOs look like at Zalando. We don't do service cuckoo / post like 99.99. We do add to wish list, 3.5 nines. View cart, 4 nines. Browse catalog, 3.5 nines. This is how we think about it. This is how we report about SLOs. This is a table that we review every week with our directors and the whole management chain. And it's much longer than that. I purposefully started with the things that don't have to react. The infrastructure KPIs come first, and you also see that the SRE department also built out the first set of SLOs. So the coverage there is relatively good, but this goes on, I think, roughly 100 SLOs that we have. The structure is 28-day SLI, 7-day SLI, and error budget. But the most value we get of the 7-day SLI. 7-day SLI tells you for the reporting period, this is a weekly meeting, was everything fine? If last week you had problems, like, for example, metric freshness, managers are having to comment. So they're basically saying, if we looked into this, there was a problem with that, we are planning to do this. So this is how we create a feedback loop around SLOs that steer reliability top-down. SLOs are the best tool to navigate the triangle. They are basically the most principled methods and the quantitative methods to do it. They don't quite explicitly allow you to put a gauge here. If you are able to make managerial steering decisions, you are able to say, okay, let's lower the SLO, let's not worry about redundancy in a data store because we can get away with not building this now. So it allows you to navigate this part. It also allows you to navigate the other part, which is interesting. And now we get to this SLO-based alerts that I before already had an example about. You can build automated alerting rules called multi-window, multi-burn rate alerts from SLOs. And then once you modify the SLO, the sensitivity of the alert will change. It will be a good alert. But the interesting bit, and that was a big kind of fight we had in the organization, was those two things are coupled. So we had situations, for example, in the payments domain, where every incident was causing a lot of paperwork for not only the context switch, but also the reporting to BaFin and so on. And the moment we touched the SLO, we created a lot of work for the teams because we were creating so many reportable incidents. And so we couldn't change our managerial ambitions because the on-call health was tanking. So this coupling was a real problem. So what ended up doing, we just decoupled. So we have actually two SLOs for all these things. One SLO, which is strictly managed by the team, could be completely separately engineered, which is triggering multi-window, multi-burn rate alerts. And then the other one is the managerial steering that happens on a whole different time frame. And actually, I think the managers should have nothing to say about how you alert. You should be held accountable if you have time to detect problems, to get your alerting in order. But your managers shouldn't tell you kind of which knobs to turn, where your pager is triggering. So this is owned by the team. This is owned by maybe a senior manager even. So there you have basically two SLOs that you want to have for each operation. Incident process. So I set for myself the personal goal to materially advance the reliability of Zalando. I really want to do that. I'm privileged with having a lot of trust in the organization, having led the SRE group, and also designed and built a lot of the tools. So I'm thinking about what do we have to do as an organization to become better at this game. And what I do is I print out the postmortems. I have a folder with postmortems. These are the Latino minds of reliability. They are like the laser beams that show you the most fragile parts of your infrastructure. This is it's an absolute treasure. And the more value you can generate out of those insights, the better cards you have to materially improve. So this is why it's so important. And that's also why this mindset around blameless incident is so important, because you want to maximize the value, and you cannot maximize the value if you're playing blame games. You have to lay the cards as open as you can, and then you have to start system engineering. You have to look at the process, the people process, the on-call health, and the technical systems that brought you into the situation so you can improve. But there is a tremendous value in having a good incident process. It's also a feedback loop. It's kind of the second level feedback loop. We looked at the incident feedback loop at the beginning. That is kind of here. And now, after the incident, we're writing the postmortem, we're reviewing the postmortem, we're deriving action items that hopefully prevent situations like this from occurring again. And then finally, we hopefully are actually following and implementing these action items, so we are in a better space. So it's second degree feedback loop we are adding. This is how it looks. We actually use Google Chat to do collaboration at Zalando. And they changed the threading structure a while back, which brought all kinds of joy to the whole organization. But the one thing which was really great is how it improved our ability to handle incidents. And I think Slack has a similar thing. So this is a training incident, but this is very much how it looks. If an incident is created, a bot generates the kind of top-level thread, which holds all the meta information. And then the actual debugging happens on the sideline. So you're opening this, and then the second panel is starting on the side. And there's the conversations are happening around the incident. And you have bot commands to change the global status, change a comment here, which is automatically updated. And if you want to get an overview of what's currently broken, you can go to the 24/7 incident chat and look at the main thread just to see what are the open incidents and what's the current status. That has made our senior management extremely happy, because just having a channel with hundreds of messages, that's undigestible. So that's, for us, that kind of structure works well. And here's like a sneak peek into the postmortem template. I didn't bother to show you a full example. It's pretty much the standard Google template. But when we summarize postmortems also in emails and so on, it's always the three things that are most important. What broke? What is the user impact? What was the business impact? What was the root cause? Do you understand the root cause? An important question to ask. And then finally, what are the actions that you commit to taking in order to improve? And just a slight tangent here, there are actually 3 levels of actions that we have. The first one is immediate action items, kind of restore the system state, make it stable. The second one is follow-up actions. That's the thing that the team is committing to doing on a set timeline. So that's the thing that shouldn't drop. So if you're opening a postmortem a year later and those things are not done, then you kind of have messed up. There's a risk of people just adding a lot of good ideas to that list, and so it becomes fluffy. And we still have that. But the process thing we are trying to do here is risk and risk management. So we have also a section, associated risks. So everything that is more diffuse and something you don't want to commit to investing to in the short term should be tracked as a risk. You just had an incident, something broke, you're not sure if it's worth investing, let's create a risk for it, let's put a mitigation strategy on it, and find a time to prioritize the mitigation. Hint, Cyber Week will be coming, we will be looking at this. So that is like on a high level how we want to handle action items. Severity is also a topic which has recently been discussed in the internet quite a bit. Here's our take on it. So the big problem is, how do you define severity, and why would you bother? And I think it's important to kind of have a really simple gauge on how big was the thing or not. But putting an exact value on it is extremely hard, so delineating the boundaries. So this is a trick I learned from a snail researcher, biologist. So they have also the problem, how do you classify different species of snails, right? Which is also, how would you ever do it? Like how large is the corpus, or I don't know, impossible. So what they do is they basically just put, they kill the animal, and they dry it, and they have it in an archive, and they say, that is the species, and there is another one. And it kind of looks similar, and then it probably is one of those. So we applied the same technique here. We just collected a bunch of postmortems, which we know for sure this is a CEF1. Significant order drop, AZ outage, CEF1. Then here, payment processor was degraded, order confirmation emails were delayed. These are CEF2s for us. And then we have a couple of CEF3 incidents that we also know roughly how they should look like. This is basically everything else. And then why do we care about severity? One thing is just in the incident, if you go to somebody, we have a CEF1 going, all hands on deck. That's helpful with communication if you already know we are in that area. But the diligence we apply to the postmortem process is informed by the severity. So it's primarily important here. So once you did a proper impact analysis, you are deciding, does your VP look into this? Does the director look into this? And does the head of engineering look into this? And they have to sign off the postmortem, and they are chairing the postmortem review meeting. So they have stakes in this, and they're directly involved. And this helps to have a higher degrees of diligence for the most damaging incidents. Here's another tip, mining the incident database. So we have around 10 incidents a week, roughly. We have a relatively high bar. This is a spreadsheet that for a quarter has all the incidents in it. And we did a little bit of reading the postmortems to categorize them, and then we create diagrams like this. So I anonymized it a little bit, so you're not quite sure what time frame and what part of Zalando this is about. But if you are writing investment pitches into reliability, like you know something that would help you advance reliability, having this analysis and being able to say, we had 5 million euros of damage done by issues like that over the past quarter. Can I take 3 weeks to fix it? It's a much better sell than I have the feeling this should be done. And this relatively low key analysis allows you to reason about this kind of things a lot easier. And the last bit I want to talk about is weekly operational review meetings. And this follows a Zalando rule of operations. It's probably a truth of management, which is called you get what you inspect. We started being very systematic about operational reviews in March last year, when we became a new VP of engineering who decided to start a global WOR meeting, global operational review meeting. And looking at the KPIs we have around incidents and looking at our global reliability stance, it's significantly improved. Significantly improved since we started, and we think we can track it down to having this meeting. We are taking 1 hour every Wednesday morning at 9 to sit with all our directors, currently like 10, 15 in this meeting, to review operations. So it's a large investment of time. And what it also is, it's a large amount of awareness that the management chain has on these issues. And just by caring and looking, the behavior of the engineering organization is changing. They don't actually need to be a lot of managerial action saying you have to fix it, but if you're reporting a KPI that is red, if you are reporting an incident for the 5th time and with a different excuse every time, things start moving. Your own ambitions grow, and at some point, some people in the management chain really start to care. And overall, this has helped us. I think we have a really good culture in that meeting, in that of being helpful and trying to identify patterns that are cross-domain. So we have a lot of the same problems with data systems at the beginning of our funnel when we are looking into like offers, and in the end of our funnel when we are thinking about orders. So let's bring those people together, like surface these things across organization and think about investments we can do together. And this is what I'm trying to do this year with a new community forum of SRE and how to improve. But I promise to show you how it looks like. This is an auto-generated report, which I think it's an innovation from last year, which I think just works beautiful. So this is a relatively small Python script that pulls reliability data from all kinds of sources and provides a Google Doc. And the Google Doc is specifically tailored to run these weekly operational review meetings. It has all the data, and it's exactly the structure. And it's Google Drive and Google Docs because we are using Google Docs everywhere, and we know how to run meetings with them, with the comments on the side and the silent reading, and we have that kind of organizational muscle. So these reports are not reports that are forgotten. They are reports that are underpinning a meeting and are underpinning a process. They are reviewed and they are used. And they are used in this warm chain. So if you look at this from a systems engineering view again, you have this kind of incident cycle. You have the department level warm, which kind of looks at this on the first level. Like, is it running well? Do we capture the right things? Do we understand the root causes? And we have a cascade. So the head of engineering sits together with the director from the infrastructure groups, for example, and he is getting up to speed with the different incidents in the different areas, because he will sit on Wednesday morning together with the other directors of the different divisions to explain what was going wrong in infrastructure. So you have kind of a hierarchy of meetings that all use the same reports that kind of are aggregating a top-down view on operations at Zalando on a weekly basis. Of course, that's a large investment, right? So we are spending a lot of time from a lot of people about it. That's for our business and our domain in e-commerce I think it's a good thing to do it because we also pride ourselves in being very reliable and have a very reliable user experience. Of course, you have to see how it translates to your domain, but fundamentally, just compiling the right information, showing it to the right people, thinking about the cadences, this is something that is very accessible and can materially improve your stance for reliability that you have globally. And with that, we are at the end of the talk. I kind of have extracted the 6 rules that I found hopefully most helpful in that. And I also want to offer you to get in touch. And this is really a sincere thing. I really love talking about reliability. I really like to understand what problems you have and what learnings you have. So if you want to talk reliability, if you have real problems that you feel like you can have a conversation with me and maybe improve, shoot me an email, use the hashtag so I know it's important, and we'll be in touch. Thank you.